We are now moving on to lesson 11, and our focus is going to be using fractions to find equivalent fractions again. So this is another warm-up, so just kind of gets your mind going. And there's really no wrong answer to these. It's just kind of getting you to think about fractions and what you notice and what different kinds of ways they can be written. So the first one, option A, you're choosing which one doesn't belong, has a fraction strip, and it shows that there are two pieces colored in, and each piece says 1/8. So we can call this 2/8. Okay, looking at this fraction right here, we have a number line. I notice 1 is over here. So it looks like we have 1, 2, 3, 4 pieces. And we have 2/4 shaded. Well, not shaded in, but shown on the number line. Okay, so this is 2/8, we said. And this is 1, 2, 3, 4, 2/4. Okay, we're looking at this next one. They just wrote a fraction. It's 1/4. And then looking at this one, oh, there's 2 on the number line, so we got to find where 1 would be. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. So that means 1 should be 1, 2, 3, 4. So this is 1 here. That's 2. Now we got to figure out where our point on the number line is. 1, 2, 3, 4. And it's 1/4. So as you can see, a couple of these have the same answer. These two don't have the same answer. So you're just looking at which one doesn't fall into a certain category. Some kids in class said, oh, this one doesn't belong because it's a fraction strip. It's not on a number line. But then they're like, well, wait a second, that's not on a number line either. Then some people said, oh, well, these all have denominators of 4, so they belong together, and this one doesn't belong. So it's kind of dependent on you. It's your opinion on which one doesn't belong. There's some different categories you could think of putting these fractions into. But for the most part, a lot of people said that these are all fractions in the 4ths, and this one's an 1/8. But couldn't we make this 1/4? I can multiply by 2 on the top and 2 on the bottom. It's a different name. So those were some of the conversations that we had. Like I said, there's no really wrong answer for this activity. It's just there's different ways of looking at those fractions. Okay, this part right here. Andre drew a number line and marked a point on it. Label the point with the fraction it represents. So you need to count the spaces in between each little tick mark there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're dealing with 12ths here. For the denominator, that's how many pieces we have. And then 1, 2, 3, 4, 5, 6, 7, 8. So this is 8/12 up here. Okay, let's see. To find other fractions that this point represents, Andre made copies of the number line. He drew darker marks on some of the existing lines. Now this was a little tricky for us to see. I was telling the kids, I'm like, wow, I don't know if my eyes can really see where the darker marks are, but I think there's one here. And I think there's one right here where the point is. And I think there's one right here. So let me see if that works out. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yep. Okay. So we just made it a little bit darker because, like I said, it's not very distinct. They didn't really mark it really easily for us to see. So that's where they're supposed to be. So now we need to label them. So let's pretend all these little tick marks aren't here. Boop, 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 boop. They're not there. Just the big lines now. So now I have 1, 2, 3 parts. So my dot's right here, believe it or not, somewhere in there, right? So that would be 2/3 is where that mark would be. Okay? Okay, now we have some different marks right here. Again, I'm going to help you because it's easier to see on my screen than on the paper. And that's where the dot is. Okay, so now we're going to pretend that this line isn't there. It's just the new lines that he drew on the number line. So now we have 1, 2, 3, 4, 5, 6 parts. And it's 1, 2, 3, 4, 6. Okay. So that was the way to do it on the number line. Now, Kieran wrote the same fractions for the points, but used a different strategy. So we talked a lot in class, and don't worry if you don't get it right now, but we talked in class a lot about fact families. And if you know multiplication is the opposite of division, then this will be an easier way of doing it. So for example, if we had a fact family and we were doing addition, let's say we did 4. We know 2 plus 2 equals 4. And 4 take away 2 equals 2. So we can do opposite. So if we were doing multiplication now, the opposite of multiplication is division. So let me show you that real quick. So what we're saying when we're saying 8 divided by 4, we're thinking about what times 4 equals 8. That's another way to look at it. So if we think of our triangle, and we have 8 here, and we have 4 here, and we have 2 here, we can say 4 times 2 equals 8, or 2 times 4 equals 8, or 8 divided by 4 equals 2, or 8 divided by 2 equals 4. Okay, so if we're checking their math, 4 times 2, it does equal 8, and 4 times 3 does equal 12. Okay, this next one right here, same thing. If we're checking their work and we're saying 4 times 2 equals 8, and 6 times 2 equals 12, they would be correct. So he wrote some fractions, but he used a different strategy. So how do you think their strategies are related? Didn't they pretty much get to the same answer? Didn't he get 2/3 and 4/6 just like Andre did? They did. They got the same answer, but they did it different ways. So you would look at, okay, well, how are they similar? Well, they broke this one. Hang on, let me clear my drawing. There we go. So they broke this one into 1, 2, 3 parts. It was a third, and each one was broken into 1, 2, 3, 4 parts. Isn't that the dividing by 4 if we're dividing it by 4? And then this one, it had 2 pieces. It broke it into 2 more parts. So isn't that dividing it by 2? So those are some of the conversations that we had. Let me see if I can make this just a little bigger. There we go. All right. So you then are supposed to use Kieran's strategy to find one or more fractions that are equivalent to 10/12 and 11/12. So what you're going to do, so that was Andre's way. So that was Kieran's way. So what you're going to do is you're going to take 10/12 and you're going to divide it by something that they both have in common for a factor. So let's think about this. When I'm thinking of things that make up 10, factors that make up 10, I can think of 2 times 5 and 1 times 10. When I think of 12, I can think of 1 times 12. I can think of 2 times 6. I can think of 3 times 4. Well, the only factors that are really in common are the 2. So I could do this. Divide by 2 on both the top and the bottom. Whatever you do to the top, you have to do to the bottom. And then I could get 5, 6. So they say to find one or more fractions. So this is kind of the only way that we could find a fraction smaller. We could go higher and multiply, like the top by 2, and cut it into more pieces. But you at least need to find one of the ways. Okay, let's exit the drawing. There we go. All right, so this is just some practice with this. So you're either dividing or you can multiply to try to find some equivalent fractions. This one is a fraction sort. You have the cards. It's a little challenging, but you're going to look at the fractions and try to put them into different piles to see how they are grouped. So some of them might be equivalent. There are some hundredth fractions in there, so you might have to do a little bit of division. The way that we worked through the fractions that had 100ths is we divided it. We thought of like quarters and how we would divide our quarters. Each quarter is worth 25 cents. We have 4 quarters. So that kind of helps us with figuring out fractions such as 1/4, 1/2, 3/4, and a whole. All right, and then this part is just explaining kind of what you've been doing. So I hope this helps, and if you have any more questions, please let me know.